Now with problem 14.6, we are looking at, I think this is a pretty easy problem right here. 14.6, let's see if we can point out a couple other things from lecture while we answer this one. So the alpha chain of eukaryotic hemoglobin is composed of 141 amino acids. What is the minimum number of nucleotides in an mRNA coding for this polypeptide chain? Okay, so we have hemoglobin, and we talked just a tiny bit about hemoglobin, how it had 4 different subunits in hemoglobin. We have 2 alphas and 2 betas, and these are all different polypeptide chains. And if we wanted to think about what is a quaternary structure of an amino acid of a protein, and a quaternary structure is just for proteins that have more than one subunit, those subunits, their 3D structure when all those subunits are together. So that's the quaternary structure of a protein. Where's the question again? Sorry, just 1 second here. Okay, so hemoglobin, and we are looking at this alpha subunit here, not the actual subunit, but we're looking at the messenger RNA. So 5' end, 7-methylguanosine cap. We're talking about hemoglobin. That's a eukaryote. We're going to have a poly A tail here, and we're assuming the introns have already been spliced out. What is the minimum number of nucleotides in an mRNA coding for this polypeptide chain? So for the alpha subunit, which is 141 amino acids long. So let's point out some things about the messenger RNA we don't need to consider. So this is the 5' UTR, untranslated. This is the 3' UTR. Now the hemoglobin messenger RNA is going to have these. But we don't need to worry about those for this problem. We just want to know the minimum number needed to be translated into this alpha subunit. So the absolute minimum number is going to be everything between here and this stop codon right here. And let's, I don't know which one of the 3 it is, but let's just go with UAG. So we need to know everything from here, how many nucleotides are going to be between this AUG and this stop codon there. So, well, this is pretty easy, right? So 141 amino acids times 3 nucleotides per amino acid. So that should be 3 times 1 is 3, 3 times 4 is 12, 423, that looks about, yeah, it looks about right. So 423 nucleotides. Now we need a stop codon, right? So we need 423 nucleotides to code for all of those amino acids, all 141 amino acids, but we know we definitely need a stop codon, so I'm going to put the 3 nucleotides for the stop codon in there. So plus 3 nucleotides for stop codon. So let's go with 426 as the absolute minimum we need for the alpha subunit. But that's not counting, that's not counting the fact that we'll have like a 5' UTR and a 3' UTR, and not counting the poly A tail either. But 426, that's a good minimum. So okay, that's the answer. That's the answer as what I think the answer is for 14.6.